Hi, my name is Nolan Quinn. I'm project manager for the Project Brightlife shelving unit. My team managers are Mario Demando on hardware, Zach Divino on software, and Bill Ambrosino as project analyst. So the project idea came to us from actually last year's capstone project, which was a very novel idea, but it was still somewhat incomplete. Originally, that shelving unit could only handle one color of light and therefore one worker at a time. The system is to allow these special needs individuals to be able to take items off the shelf based on the colors of light that they're assigned to. So we wanted to upgrade that to 3 people, or at least. And additionally, there were some other various issues which we'll get into later. So when we first heard of that coming back to this project was an option, we were a little hesitant for various reasons. We felt that some things were a little off about the last project, like maybe the documentation wasn't there. I think this is a problem with any project that you have picking up where someone left off. So, but when we first saw LifeSpire and the company that we're helping out, when we heard what they do and what they help these individuals achieve, we wanted to be part of that, and we wanted to get in on that. And that's, I think, where that initial intrigue comes from. So again, we first picked up that project from the previous year, and again, it was a very good idea, and it was pretty well made. There were some technical challenges. As I said before, there were only one color of light, which means only one person could handle a shelving unit at a time. So we have upgraded the system to do 3 different colors of light right now, and it is able to program more colors of light later on. So that allows for multiple individuals to be sharing the same shelving unit at a time. Additionally, there were some issues with the scanning system. When we first looked at it, we wanted to figure out how could we get these individuals to be sure that the package that they're picking up, the items that they're picking up from the shelf, go into the right package. And so the original team did look at RFID scanners. And at first we were also a little hesitant about that, but we came back to it, and now we're working on portable handheld RFID scanners for these employees to track the items that they are taking off the shelf. So first of the team managers that I picked for hardware was Mario Demando. He's really passionate about what he does. He gets really involved, and he puts in a lot of effort into the work that he does. And I really like that in somebody who's going to be leading the hardware team, especially on a project with this scale and scope. For software, now I do say that Zach is the leader of that team, but in reality, it really is a combination of both Zach and Kenny working together on this. There are 2 people, and they work really well together, remarkably well. And I think that letting them not so much have one lead another, but as working as a team, they've accomplished a great deal for the scope of the project that we have at hand. As for the project analyst, I wanted to pick somebody who I thought really could shine in a role and maybe hasn't had that chance to the extent that they could show off what their skills are. And that's why I picked Bill. He really knows how to make a clean presentation. He knows how to follow the rules of the work that we're doing. He knows how to make that kind of report. And I really appreciate that in somebody who's going to be making the report that we had to make.
How are you currently attempting to
biggest problem was that they were going to be scaling up a project that was completed last year and making it much more complicated. So they were talking about having hundreds of LEDs that they were going to have to control. And what always comes up there is that it's the software component. It looks like the hardware is going to be the hardest part of that, because there are so many LEDs and so many device drivers and so many wires and so many cables that need to be hooked up, that they always end up underestimating the complexity of the software to control all of it. And they usually end up leaving that to the very end, and that's kind of what they've done again. So they're under pressure now to try to get all of that software stuff written.
So the biggest issues that we had going into this were the scanners, but by far were probably the most convoluted thing we had to come up with. Because every time we looked at it, at the issue of how do we know that these employees took the items off the shelf and put them in the right box, we came across the issue of maybe they lost it somewhere, or maybe they didn't take off the right item. How do we know for sure? So when we started looking at that, we looked even at things like vision tracking, reading the labels on the product and converting that to a text. We looked at using some kind of fixed RFID scanner where it would be a chute almost. But the issue is that we weren't able to get the RFID tags on the individual items of clothes, which caused some issues with that plan. So eventually we were looking around and we came up with this idea of handheld scanners. And at first we were looking into Bluetooth communication, but we figured out that these little radios called XBs would give you great range and really helped out. Another issue was the software, and that's something we're still working on. While we have exemplary programmers in both Zach and Kenny, it's still a small team. And so cranking out this massive piece of software that's going to be required is going to be a challenge in the coming weeks. So one issue is with the LED lights. Now, as I mentioned, we're going to now 3 colors. And one may say, 3 more colors, that's 2 more than we already had. That's not that hard. It is. It is that hard. Originally, the previous year's capstone team had 1-to-1 ratio of an output from our control board to the lights on the shelf. So that means that for every 1 light on the board, on the shelf, there would be 1 output pin on the microcontroller, which is controlling all the lights. But the thing is, so this board that we're using is called the Arduino Mega. It only has, and I say only, it has 56 outputs or so. So that means that we can only have 50 or so lights. And if we're doing 3 colors for a 5x5 shelf, that means we need 75 lights. And in general, just using that many output pins is just a hassle. So we realized that we can do something called multiplexing, and we're using shift registers. So one of these shift registers can take 3 outputs from the Arduino and convert it into 8 more outputs. And that means that, and additionally, you can daisy chain them. And this is this weird thing where if you actually hook one up right to another, you can just keep using those same 3 outputs over and over and over again. As for the RFID, as I mentioned, we're using these portable scanners, and again, we're using the XP radios. It's really neat, and something I've been curious as to how it works, and finally getting the chance is really cool. So each shelf will have a RFID tag associated with it, and you can assign whatever article of clothing is on that shelf to that RFID tag's identification number. So once I tap this portable scanner on that tag, and another great thing is it's not dependent on orientation. So the workers can put them in however they want, these scanners, and it'll pick up the data. So when you tap our little scanner on these tags, it will relay the data back to a central computer program that which Jack and Kenny are working on, and it will see that this shelf has had an item taken off of it. I'm going to shut off the light on that shelf. And as for the software, again, massive undertaking. We want to make sure it's as configurable as possible. That has room for expansion in the future for even multiple shelves. And being able to interface with all the lights and microcontrollers and scanners that we have is a novel thing to be working on, to say the least. So this here is the real heart of the Project Brightlife system. This is the control board prototype that will be used to light up the shelving units for the workers. So we look closely here. We see that this is the Arduino. It is an Arduino Mega. And this is the real heart of the board. And this was the same type of microcontroller that was used in the 2014 design to control the lights. In the previous year's design, the original LEDs were hooked up to each one of these pins here, and they each required one pin to be lit up. When we switched over to a system requiring 3 LEDs for 3 colors, we needed to change the system to have more pins, and we accomplished that by doing LED multiplexing. To do this, we require shift registers, which are these black integrated circuits which you see here. These circuits are controlled by the Arduino and are able to take 3 pins for all 3 of these circuits and control many more LED lights. This allows us to increase the number of colors like we wanted. Over here, since we're dealing with 12 volt power supply, 12 volt DC power supply, we had to be able to control that with the shift registers and the Arduino. Naturally, these shift registers and the Arduino cannot handle a 12 volt DC source. So, to act as an intermediary, we use these P-channel MOSFETs here. They allow us to control greater voltage levels very efficiently, which allows us to control all of our LEDs. Each one of these MOSFETs is actually a column in the shelf. In the final design, 5 of them will be hooked up in line to control the 5 different columns of the 5x5 shelf. To control the colors and the rows, each row has 3 colors, which means that the LED has 3 cables coming out of it. There's 1 cable coming in from the column and 3 cables coming in from the LED. And these cables are in turn hooked up to the shift registers here, the 2 lower ones. So by using the Arduino and LED multiplexing, we can turn on the colors individually so that the workers know what color that they're assigned, and they then know what items to take off the shelf. Here we see the Arduino will be receiving serial data over USB from the main computer. In the ideal system, the supervisor will be able to upload orders to their computer and send these orders to the Arduino. Based on the contents of this order, that will determine what shelves are lit up and what color the shelf should be lit up in, optimizing the workload for each worker. So over here we see our RGB LEDs. They are able to light up in a variety of different colors through mixing, but for simplicity's sake, for the workers, we have opted to use 3 colors, the 3 core colors, red, blue, and green. In this prototype setup, which is here just for demonstration purposes, These two LEDs are in column 1. So that means that these are both being controlled by the one P-channel MOSFET over here. When this is on, these LEDs will be in control. These two LEDs are in column 2 and thus are being controlled by this P-channel MOSFET over here. So, in reality, only one of these MOSFETs can ever be on at one time. But, thanks to human persistence of vision, we can cycle the LEDs faster than what the human eye can see. So, despite the fact that the LEDs aren't always on, they appear to be always on. And that's how we're able to control so many LEDs as well. So, for example, if I want to light up this LED, which represents column 1, row 1, green, in this demo, we have it set up that it will receive serial data through the Arduino and light up green when a button is pressed on the user interface. Similarly, the same can be done for row 2, column 1, in red. Column 2 can also be set, and this time demonstrating blue for row 1. And again, green for column 2, row 2. And of course, all of these LEDs can easily be shut off. While this has been done through a simple user interface in this program, in this demo, the actual user interface will be much more complex and be able to automatically turn on the lights based on the orders. This is the next important part of the Brightlife system which we have developed for 2015. This is an RFID reader. Now, unlike the previous year's design which needed one large fixed reader, we are able to make multiple wireless RFID scanners that are handheld. This here is the Arduino, which is the brain of the operation again. Connected to it is this RFID scanner and this XB radio. Attached to the operator's computer is another XB radio connected by USB. These two are not connected physically in any way. When the workers go to take an item off the shelf, they will tap one of their handheld scanners, RFID reader, to a RFID tag located on the shelf. Each tag has a unique identifying number to it. In the code, the system will know what shelf corresponds to what numbered tag. When the worker takes the item off the shelf, again, he will touch the scanner to the tag on the shelf, and that will check to make sure that the right item has been taken off the shelf. If the shelf is lit up in that worker's color and the worker taps that tag, the shelf light will turn off, indicating that the worker has taken the right item for the order. Otherwise, this little red LED will turn on, indicating that the worker has taken the wrong item and it needs to be put back onto the shelf. As part of our demonstration, we will show the unique identifying number and the wireless capabilities of this scanner. Here's the first RFID tag. We tap it onto the box, and wirelessly, as you can see on the computer monitor here, the identifying number of the tag is displayed. This is different for every tag. So this next tag, if we see this number ends in A5119E, if I tap a different tag, we now have a number ending in 7493CD. Again, each unique identifying number lets us know what item has been taken off the shelf by the worker, ensuring the accuracy of each order. Additionally, in the GUI, we will be able to track the number of items left in inventory on the shelves. And we will show that in a moment. What you see here is the GUI, our graphical user interface for Project Brightlife. Here we see a layout of the shelves, again in a 5x5 grid to accommodate a 5x5 shelving unit. In these boxes we can enter what items are in each shelf, and in a small corner of the box we see how many of each item is in that shelf. Additionally, workers can be assigned orders, one box for each worker at the bottom of the screen. If a worker does not have an order and an order is available from this fourth box, that order will be assigned to that worker. Orders are uploaded from an XML document that is provided by the supervisor. Additional shelves can be scrolled through, as ultimately we hope our system can have more shelves. Unfortunately, right now, much of the user interface is not entirely operative. While it can now save states of different items, that is, it can retain its information when you close it and quit it and reopen it later. Much of the hardware interfacing was not accomplished during this semester. Hopefully, we will be able to finish this at some point.